All right, advanced math 8, here we go. We've got lesson 6.3.1, solving systems using elimination. So this is our last of our 3 solving methods that we're looking at for systems. We've already done the equal values method and the substitution method. So this next one is called elimination method. And based on this problem right here, we're going to see why we don't always want to use substitution. So it says use substitution in this equation. Well, for what? Because you've got x's and y's and x's and y's. Nothing is isolated. So I guess I got to do it myself. So let's go ahead. What's going to be easiest? The x's. Let's get this x by itself because I can't substitute until I've isolated. So let's see. I'm going to, oh, it could be tricky. I'm not going to do it. All right. So here's what I'm going to do. I'm going to subtract 3y from both sides. And I'd get 2x is equal to negative 3y minus 2. And then I'm going to divide everything by 2 and get x is equal to negative 3 halves y minus 1. All right, I have isolated x, so now I can substitute. So I'm going to take negative 3 halves y minus 1. I know that's what x equals. So I am going to substitute and plug it into this x right there. So when I rewrite that first equation, when I get to x, I know that x equals negative 3 halves y minus 1. So we're going to do 5 negative 3 halves y minus 1 minus 3y equals 16. I need to distribute. So this gives me negative 15 halves y minus 5 minus 3y equals 16. This is kind of ugly. Okay, let's multiply everything by 2 so that I can get rid of that fraction there. So I'm going to multiply everything by 2. This is messy. Negative 15y minus 10 and then minus 6y. So everything has to be multiplied by that 2. Then over there I got 32. Okay, now it's getting a little bit better. I get, let's see, negative 21y minus 10 equals 32. I'm going to add 10 to both sides and get negative 21y is equal to 42. And divide, finally, okay, so I get negative 2 when I divide by 21. Phew, I'm not done yet. I need to find out what x is equal to. And I really want to plug it into one of the original equations because I might have made a mistake here. So let's plug in negative 2 into this one. So I'm going to do 2x plus 3, and instead of y, I'm going to plug in negative 2, and then equals 2. So this is 2x minus 6 equals negative, that was a negative 2. I'm going to add 6 to both sides, and I get 2x is equal to 4, so x is equal to 2. All right, so I think my answer is 2, negative 2. Do I know my answer is that? No, I think it is. I'm fairly confident. To be 100% sure, we need to plug it into this equation because I know it works for this one, but I don't know if it works for that one. So I'm going to do 5 instead of x is 2, minus 3 instead of y, that's negative 2, equals 16. So this is 10 plus 6, ah-ha-ha, ah-ha-ha, 16 equals 16. Boom. Okay, I was right. Now I know I was right. Okay, so we want to go for efficiency. This is inefficient because I've got so many places I could have made mistakes. I could have made a mistake getting x by itself over here. I could have made a mistake over here with this fraction and then all this other work that I had to do with it. So we want to stay away from inefficient solving problems because inefficient can mean that we're going to make mistakes. So instead, on this particular problem, it works way easier when I use the elimination method. Now, the elimination method is a form of equality where we say 5x minus 3y equals 16. Now, could I add 5x to both sides? Yeah, I could add 5x to both sides. Could I add 5x minus 3y to both sides? 5x minus 3y to this side and 5x minus 3y to that side. Yeah, I could do that. Could I add 16 to both sides? Yes, I could do that. So I could do all those things. I could add 5x to both sides. I could add 5x minus 3y to both sides. And I could add 16 to both sides. Those are just properties of equality. If I do something to one side of the equation, I can do something to the other side of the equation. Well, what I have here is an equation. They equal each other. This equals this. They are the same exact thing. They don't look like the same thing, but in that equation, we're saying they are the same thing. So what I can do is add this to one side of the equation and then add this to the other side of the equation because they equal each other. So my equation's still going to balance out. So I'm going to add 5x minus 3y to this side of the equation. On the other side of the equation, I'm going to add 16. And this is completely okay to do because this equation says they're equal to each other. I'm adding the same number to both sides. 16 is the same as this. So I'm adding 5x minus 3y to this side of the equation. I'm adding 16 to the other side of the equation because that equation says they're the same. So on the purple side, I got 2x plus 5x, that's 7x. 3y minus 3y, y's are gone, equals negative 2 plus 16, 14. Divide by 7, x is 2. X was 2. Now I ask you, which one's more efficient? That. How many places could I have messed up on this one? Like, hardly any. Look at all the work I did up there. That's a lot of places to mess up. This is not very many places to mess up at all. Okay, so sometimes on certain equations, elimination is the way to go. And basically, we're just using properties of equality that says if I add some number to one side, I can add the number to the other side. Since these are both the same, I can add them to either side of the equation. Now, we're not done, of course. We should have plugged in 2 to one of the equations, so I'm going to go ahead and do it. So 2 times 2 plus 3y equals negative 2. So I'm plugging into this one. So I got 4 plus 3y equals negative 2. I'm going to subtract 4 from both sides. 3y equals negative 6. And y is negative 2. Just like we set up there. Same problem, more efficient way to do it. Look at all that work up there. And then look at the work down here. Technically, we're not done because we should plug it back into this one, but we already know that it works because we did it right there. All right, there you go. That's the elimination method. Okay, next problem. Pat was fishing in a fishing competition at Lake Pisces. He caught some bass and some trout. All right. Each bass weighed 3 pounds. Bass are fighters. You really want to catch those. And each trout weighed 1 pound. Now, trout tastes good. So do you want to fight or do you want the trout? I usually just throw them back, so I'll take the bass any day. All right. So anyways, we got 3 pounds for the bass and a pound for the trout. Okay, sounds good. So Pat caught a total of 30 pounds of fish. Okay, so total, that means something's going to be equal to. Knowing that the bass weighs 3 pounds, that's important. And the trout weighs 1 pound, that's important because this is the total pounds right there. So that looks like an equation I can make. Okay, on top of that, he's getting 5 points in the competitions for the bass, but trout are endangered. Wah, wah. He lost 1 point for each trout. Pat, what are you doing? Why is he keeping the trout? If you're losing points, just throw him back, you fool. What a dummy. All right, anyways, Pat scored 24 points. Okay, so that's equals 24. All right, let. We need to write our let statements. My nose is running. Okay, so we are going to let B equal the number of bass. Okay, that's something I need to know. B equal the number of bass Pat caught. And then I'm going to let T equal the number of trout that he should have thrown back, but he's a dummy. So B is the number of bass, T is the number of trout. Sweet. We want a system, so we need 2 equations. Now, in this problem, I have 2 totals. One is the total for the pounds of fish. So let us go ahead and write one of our equation to equal the total pounds. Now, I know that the bass weighs 3 pounds. So 3 pounds for each bass, plus 1 pound for each trout. That's going to equal, here's my total bass pounds, here's my total trout pounds. That's going to equal 30 pounds of fish. Next one. We've got, 5 points for bass. So this next one's going to be for the number of points. So 5 points for a bass. He lost a point for the trout, minus 1t, and his total points is 42. Wouldn't this problem been so much easier if he just would have thrown the trout back? Because then it'd be 5 bass equals 40. Oh, sweet, done. No. Bass. All right, so at this point, what can I do? I'm going to use the elimination method because when I do, if I add 5b minus 1t to this side of the equation, the trouts eliminate. That's why it's called the elimination method. So we're going to eliminate the trout over there. So I'm going to add that to that side. And then to the other side, I'm going to add 42 because 5b minus 1t equals 42. So I can add this one to this side and this one to this side. So I get a total of 8b when I add these 2 equations together. And the trout eliminate, which is why it's called the elimination method. So here we got 72. So divide by 8. He got 9 bass. That's a pretty good day. So he's got 9 bass. There we go. I got my answer. Now if I want to find out how many trout he caught, we can solve it by plugging 9 back into one of these 2 equations. Let's do it to the top one. So I'm going to do 3 times 9 plus t equals 30. So this is 18 plus t equals 30. So t must be 12. Dude caught 12 trout and didn't throw them back. Anyways, now to double check our answer, we would plug it into this other one here. 5 times 9 minus 12, does that equal 42? Okay, 5 times 9 is 45 minus 12. That does not equal 42. So here I get 33 equals 42. Problems. So we got a problem there. These do not equal each other. So this means I made a mistake. And do you see the mistake? Do you see it? 3 times 9 is 27, not 18. So smart. So the trout is actually 3. So this is how we check our work. Okay, so if you make a mistake, you'll find out right here. And then we go back and we find where we made the mistake. All right, so you want to do this step every single time. Now I'm going to retry it and see if I'm getting the right answer now. So 5 times 9 minus 12. So I get 45 minus, that's supposed to be 3, not 12. So 45 minus 3 is 42. Okay, now I know for sure that I got the right answer. Okay, so there are 9 bass that he caught and 3 trout. See how that works? That's how you find out if you made a mistake. If I had to, I'm pretty sure of this. I'd say that systems problems are probably the easiest problems to make a small mistake on because there's so many steps. You really have to do this last step because then you're going to tell me that there are 9 bass and 12 trout or something silly like that. When if you plug it in, you can easily see that there's a mistake somewhere and then you can go back and find it. All right, so we want to do this. All right, so why would the elimination method work best for this problem? Because the trout eliminate. We've got opposites for the number of trout. So the trout variables are opposites, which makes them eliminate. I think I got ahead of myself. All this work was supposed to be down there. So just pretend like I did it like that. It's been a long day. All right, every time I do these problems, people say, why didn't you just teach me elimination first? Well, all the problems that we've done before haven't been set up nicely like this. Elimination we really want to use when we have both of our equations in standard form. Now, could I have used elimination on all those problems that I've done before now? Yes. I could have done substitution on this one if I wanted to. I could have done equal values method if I wanted to. It just so happened on this problem, elimination was probably the best method to use. We'll have a section later on where we just look at the problem and go, okay, should we do equal values? Should we do substitution? Should we do elimination? Which one is best? All right, so Annie was going to use the elimination method, and she was ready to add the same value to both sides of the equation to eliminate the x terms when she noticed a problem. Both the x terms are positive. They're not opposites. So if she adds this to this side and 5 to the other side, the x's don't eliminate each other. So what can we do to fix this? Well, if I want the x's to eliminate, this one would have to be positive 2x, and this one would have to be negative 2x. I can actually fix that. Here's what I could do. I could multiply both sides by -1. If I multiply both sides by -1, this is the multiplication property of equality, so it's okay to do. I would get -2x minus 3y equals negative 5. And now the x's would eliminate. So it's not always going to be where they give it to you real nice, where they automatically eliminate. Sometimes you got to do a little bit of work to make them eliminate. So let's go ahead and solve that to show that it works. So I'm going to stack these two on top of each other. 2x plus 7y equals 13. On this side of the equation, I'm going to add negative 2x minus 3y. On the other side of the equation, I know that 2x minus 3y is equal to negative 5, so I'm going to put negative 5 on the other side of the equation. All right, I've stacked them. Now I'm going to combine like terms. The x's are canceling just like I wanted them to. 7y minus 3y is 4y. Over here, 13 minus 5, 8. So y is 2. Okay, so we need to find our x value as well. So let's just take one of our equations. Let's take the second equation here. We want to use the equations we started with because maybe I made a mistake. So I'm going to do 2x plus 3 times y, and y is 2, equals 5. So 2x plus 6 equals 5. I'm going to subtract 6 from both sides. So I get 2x equals negative 1. So x is negative 1/2. And you're looking at it going, oh no, I got a fraction. I did it wrong. Fractions don't mean you did it wrong. The answer might be a fraction. So how do we double check? We plug it into the other equation. So let's go ahead and do that. So I've got 2. X we're saying is negative 1/2. Plus 7y, and y we're saying is 2. Do they equal 13? Well, 2 times negative 1/2 is negative 1, plus 14 equals 13. So 13 equals 13. I know that I'm 100% right. I got a fraction, and you might think, oh, it's wrong because I got a fraction. No, you're not. You're not wrong. That was the answer. Negative 1/2 and 2. That's your answer. All right, so this is just practice here. Practice the elimination method. So I walk up to the problem, I look at it. Do I need to do anything to make anything eliminate? No, because these x's are going to eliminate here. So all I have to do is take negative 3y plus x, put it over here, and take negative 9 and add it to that side. I get negative y over here. The x's cancel, and negative y is equal to negative 4. So y equals 4. Now I'm going to check to see what my x value is going to be. So I'm going to plug in 4 into this equation. So negative 3 instead of y, I'm going to plug 4 plus x equals negative 9. So this is negative 12 plus x equals negative 9. I'm going to add 12, and x it looks like is 3. I think that's my answer, but to double check to make sure it is, I'm going to plug it into this equation because I already know it works for this one, so I'm going to try this one. So 2 times 4 minus 3, does that equal 5? Well, 8 minus 3 does equal 5. So now I know 100% that I am correct. So my answer would be 3, 4. That is where those two lines would intersect. Okay, next one. I've got 4y minus x equals negative 3. And over here I've got 2x minus 4y equals 14. Now on this one, is anything going to eliminate? Yes, the y's are. Positive 4y, negative 4y. I'm going to flip it around a little bit. Instead of writing 4y minus x, I'm going to write negative x plus 4y. That's okay. You can do that. All right, you can switch your order. Is that the commutative property? And then on the other side, I'm going to add negative 3. All right, so over here, 2x minus x, that gives me x. The y's cancel. And then I get equals 11. So x is 11. Sweet. But what's y? Let's plug it in and see. So I'm going to plug in 11 over here. So 4y minus 11 equals negative 3. I'm going to add 11 to both sides, and I get 4y equals 8, and y must be 2. So I think my answer is 11, 2. I'm going to double check by plugging it into this equation here. So 2 times 11 minus 4 times 2, does that equal 14? So I got 22 minus 8, and 22 minus 8 does equal 14. So I know that I'm right now. So my final answer is 11, 2. Last one. We've got 3x plus 4y equals 1 and 2x plus 4y equals 2. Problem. These are the same. If I combine them, I'm going to get 8y, and they're not going to cancel. So I'm going to multiply both sides by negative 1. And I would get negative 2x minus 4y equals negative 2. And now the y's would cancel each other out. So negative 2x minus 4y equals negative 2. So the x's just gives me x, and 1 minus 2 is negative 1. Okay, I've got my x. Now I need my y. I'm going to plug it into this one right here. So I'm going to do 2 times negative 1 plus 4y equals 2. Negative 2 plus 4y equals 2. I'm going to add 2 to both sides. 4y equals 4. And y is 1. So I think my answer is negative 1, 1. Again, I'm going to check. So I'm going to plug it into this equation. 3 times negative 1 plus 4 times 1. Does that equal 1? Yes, because it's negative 3 plus 4. And that is 1. So 1 equals 1. I know I'm right. So my last part is to write down negative 1, 1 is my answer. Done. That's it. Go take a nap. See you guys later. Math hard. Bye.